Good afternoon, students. Okay, today we are going to learn about the simplification of the context-free grammar, and if the time permits, then the introduction to Chomsky normal form. Okay, so we are learning the topic that is context-free grammar. But before starting of the lecture, I just want to announce that our Institute Innovation Council got 4.5 stars out of 5. Because I'm very happy because I was looking after the council, that is Institute Innovation Council, and you must have received the message uh, in your WhatsApp group regarding applying for the IIC team as a student member. Okay, so I just want to tell you that we have extended the date for application for working in the council, and you can apply for that. And it is not only studies for your placements. You will have to show that what are the extracurricular activities that you have done. And this is a good opportunity. You can work as a, like, there are many posts are there, starting from the council head plus documentation administration in charge, and some good posts are also there. So if you have missed any opportunity, and if you're not working in any other council, you can apply for IIC work, where you will have to deal with the working and entering the data into the IIC MHRD website. I just want to tell you in brief, like this MHRD, that is Ministry of HR Department. They have started this initiative from last 3 years. This is the third year. We have worked for 2 years before, and we have got 4.5 stars out of 5. And there are around 2,000 institutes all over the India. They are working under the guidance of MHRD. MHRD, that is Ministry of HR Department, that is in tie-up with AICTE, and they give us some guidelines, and according to the guidelines we have to perform, or we have to conduct the activities within the institute. So all other councils, they are by default the part of IIC. IIC is not like as other councils. All the councils are the part of IIC. Okay, so it is not going to participate in any competitions like Crescendo or something like that. It is a group of all the councils is called as IIC, and we represent our institute to MHRD, and we showcase our activities which are happening within the institute to the government of India. Okay, so we are IIC is the interface between that MHRD, Ministry of HR Department, and our college. Okay, and there are many events, all the events which are happening in the institute that are to be reported to them. So there is a work in the background, and for that we are forming a team. We will have to have a website also. And the one of the major activities that IIC conducts is about conducting the idea competition with a council. Last time we did with ECL council, and in that competition we asked the students to apply for a good idea and to develop a project on that idea, and it can be converted into a product. So that competition will be there within 2 months of time. And if you have not applied, then you can apply, because in your placements, no, you will have to show everything. Your technically you should be sound, your CGPA should be more than 7. Then your data structures, analysis of algorithms knowledge should be properly done. One particular language you should have, plus you should have some leadership qualities. You should have done some extracurricular activities. You should have participated in multiple competitions, and you should get show the some prizes and all. Okay, so if you have nothing to show your leadership qualities, then you can join in the council, and we will give you the certificate that will be helpful for you when you are preparing your resume for the next year. Okay, so if you have not anything in your hand, please immediately you can contact to me, Kranti, or Yash, who was the president last year. Okay, because we need people working for the council, and it is different than other councils. Just remember, all the councils are the part of IIC. IIC is not in competition with any other council. All the councils together is called as IIC. but there is some background work, and for that we are searching for people. Okay. Okay, so let's start with the any doubts you can contact us and write the message to me or Kranti ma'am or Yash. Okay. So today we are going to solve two or three problems of simplification of the context-free grammar, and after that we will, if the time permits, we will see the Chomsky normal form. Now, for this particular chapter, only two topics are remaining: Chomsky normal form and Grayback normal form. Okay. As you know, what is context-free grammar? It is a type 2 grammar as per the Chomsky hierarchy. Suppose you want to invent your language, the language should have a particular grammar. Chomsky normal form is a type 2 grammar. It can be identified by the machine, that is push down machine. So after this chapter, I'm going to start again with the machines kind of problems where there is an input tape and read write head and there is a stack. Okay, such kind of problems will be there, which are interesting problems for PDM. Okay, so CFG is a grammar for the language, context-free language, and it is a type 2 grammar. And the rules are of the type of A generates alpha, where your left-hand side is a single variable and right-hand side is the combination of variables and terminal symbols. And the machine that I can identify this language is a push-down machine. Okay. Now, this representation of the grammar can be seen with the help of a parse tree for a particular word. Okay, so the grammar has, or the language has, a set of words. For you can take a particular word and how to parse the word or how to parse the sentence of the language. For that, you can create a tree, and with the help of a tree, you can visualize the parsing, matlab how to execute the statement. That parsing is visualized with the help of a parse tree. So when you are working with context free grammar, you need to know how to design the context free grammar, how to draw the parse tree for a particular word. For drawing the parse tree, you can have a leftmost derivation as well as rightmost derivation. In case of leftmost derivation, always you go on solving the leftmost variable, and in case of rightmost derivation, you always go on solving the rightmost derivation, rightmost variable for the first time. So priority is given to the rightmost variable in rightmost derivation. In leftmost derivation, the priority is given to the leftmost variable. So this is about LMD and RMD of a parse tree. And if for a particular word, if you are able to draw two different parse trees, it is a trial and error method. For a particular word, you have to identify a word of the language, and for the word, if you are able to draw multiple parse trees, then you can prove that the given grammar is ambiguous. Means the rules are not written properly and the rules are ambiguous. So multiple parse trees are possible. If multiple parse trees means compiler will get confused how to execute the statement. It can be executed in multiple ways, and then compiler will not be able to understand how to execute the statement, and it is an error. So your grammar should not be ambiguous. It should be unambiguous grammar. Okay, so there are topics like how to identify the ambiguous grammar. And if it is ambiguous, you can remove the ambiguity. For removal of ambiguity, there is not much weightage given in the exam, but sometimes they may ask. But there are 3, 4, or 5, 6, maximum 5 problems are there which are asked again and again. So you need to do that problems carefully, because there is no hard and fast technique to remove the ambiguity. And the technique is that you can go on adding the variables and remove the ambiguity. And you postpone the calculation which is the highest priority. Lowest priority calculation should be done first with the help of a newly added variable, and you postpone the highest priority calculation. Okay, this is only the technique that you need to remember, and you have to rewrite the grammar and check whether the ambiguity is removed or not. Okay, so I suggest you that for that particular removal of ambiguity, refer the question papers and solve the problems, and keep it ready. And any one of the problem will be there in the exam, because they have not asked any new problem in the last many years. I have uploaded all the question papers on your classroom. Okay, so in case of any doubt, you can ask me. Like if you're not finding the papers are actually there in the classroom. Then the next topic that we studied is about simplification of the context-free grammar. In the simplification, what is the first step? Remove useless productions like empty productions. Remove epsilon productions, then remove null productions, and then remove the useless symbols. And there are two types of useless symbols. Which are they? Uh, your useless symbol can be a non-generating symbols or non-reachable symbol. Okay, so we are on the topic of simplification of the context-free grammar. We'll see one or two problems of simplification, and I'll introduce you with the CNF. And then next time we will see CNF, full-fledged problem. Okay, or if time permits, we'll do it now only. Okay, so let's see simplification of the context-free grammar. The question is to simplify the context-free grammar. And now the grammar is given to you. You are having four variables S, A, B, C, and there are two terminal symbols small a and small b. And the rules are given to you, and you have to simplify this grammar. So for the simplification, the first step is to identify and remove null productions. So identify what are the direct null productions. Here the direct null production is C is equal to epsilon. So if C is equal to epsilon is a direct that you have identified. Now let's go on seeing all the rules. The first two rules, if C is epsilon, nothing is going to change. In case of A, here we cannot do anything. Like we are not able to identify. Okay. So let's start from the second last rule. Like after C, first you try to check for B. Productions. Now here A, B and C are epsilon. So now you can check whether S can be epsilon. So if both of them A and B are epsilon, then S will also become epsilon. So now we can say that all the symbols are nullable symbols. Okay. For this particular grammar, we first step is to identify and remove null productions. So here we have done identification of all the null productions. Actually, in the grammar, only C is equal to epsilon is given. So it is a direct null productions. We have to remove it. But if we observe this grammar, I started from S, but I was not able to find out. So I started in the reverse order. Okay, so in the reverse order, if I'm searching that whether B is epsilon, okay, B is epsilon because B is equal to C. Now, if I say A is equal to B and if B is epsilon, then A is also epsilon. So I can say that C is epsilon, so B is epsilon, and because of B is assigned to A is also epsilon. And if A and B both are epsilon, then S is also will becoming epsilon. So because of these rules, S is equal to AB, A is equal to B, and B is equal to C, all the symbols are nullable. Okay, so identification is done. Now we have to remove it. Okay, so in the removal, start taking one by one all the variables and try to remove them. Okay, so what I'm doing now, I'm taking, so I give you a trick to solve the problem without any confusion, that always you start from the last variable and then you take S at the end, and then it becomes a simple problem. Otherwise, you will have to do it in the multiple passes. Okay, so if you want to do it only in one pass, like going through once with all the rules, then you start from C. So I'm trying to remove C now. C is equal to epsilon. Okay, so for C is equal to epsilon, what I'm doing is that I'm writing the grammar as it is without C is equal to epsilon. Okay, so see here all the rules are there. Now I have rewritten the grammar here, but only C is equal to epsilon is not there because I want to remove it. But if I want to remove it, then what I have to do? That I have to go through all the rules. And if C is equal to epsilon, what are the changes that I have to identify? So here I'll see that if my C is epsilon, then here there is no change. Here if C is epsilon, A is equal to B, but it is already there. Matlab here I have added, it is already there. So no need to write it again. Or if you write it, then in the final answer, you remove the duplicates. And then C is equal to epsilon. And so there is no change, no other change. Now you take B is equal to epsilon. Okay. So for B is equal to epsilon, first you write all the set of rules as it is. Okay. And now here you look at here. So assume that it is written here. Now you for B is equal to epsilon, you try to check what is the change in S. If your B is epsilon, then S will become A. So I have added here S is equal to A. Now if B is equal to epsilon, then S is equal to small a. So I've added here S is equal to small a. Now go to the next rule. Here if B is equal to epsilon, A will be C. So here after this C is added. Okay, here. Now B is equal to epsilon, so it will be, we are going to consider it then unit productions. Or here there is no other change. Okay, so no other change. So for B is equal to epsilon, the addition is S is equal to capital A and S is equal to small a and A is equal to capital C. This is the change. Okay, now consider this grammar as input and try to remove C is removed, B is removed, try to remove A. Like for A, what is to be done? Okay, so again for A is equal to epsilon, now go through all these rules. Now this is your input. This is your input to the step. Output of one step is the input to the next step always. Okay, so for A is equal to epsilon, if I remove A, S will be B. So that is added here. Okay, it is added here in the B. Now go through this, go to the second variable. If A is equal to epsilon, no change. A is equal to epsilon, no change. And now go to the next here. If A is equal to epsilon, no change. So everything is written as it is. So for A is equal to epsilon, only one change has done. That is S is equal to capital B. Now after that, take the final one. That is S is equal to epsilon. So for S is equal to epsilon, try to check whether there is any change in this. There is no S here. So if S is equal to epsilon, we cannot do anything. So it will remain as it is. Here also there is no S at the right hand side. Here also there is no S. So there is no change. And the same grammar is the output of the step one. So the overall, the first step of simplification of the context-free grammar is identify and remove null productions. So for this entire step, this will be the final, this will be the output of the step. For this step, this was the input with epsilon production and with this many number of productions. Like S के लिए तो 2 ही rules था. Now S के लिए there are 5 rules. Okay, so this was the input to the first step, and now the output is having this many production rules. Okay, so now you consider this as a input to the next step. Next step is so this is the input, this is the first step ka output. Okay, uh, now and then the next step is identify. Step 2 is simplification ka. Step 2 is identify and remove unit productions. Okay, so now you identify all the unit productions. So a unit production for S is equal to A is here, S is equal to B is here, then A is equal to B is there, then A is equal to C is there, and B is equal to C is there. So there are around 5 unit productions. Okay, here also you start from C. If C is equal to something, then start from C. Now here there is no unit production, so start from B, then A, and then S. Then your problem is easily solved. Okay, so now we have to we have identified. So for from the step 2, we have identified all the unit productions. They are written down here. Now I want to remove them. So select this rule B is equal to C. Rewrite the grammar without unit productions. So rewrite the grammar S is equal to AB, small AB, then only small a. So this is removed and it is kept here. Then A is equal to B and A is equal to C is also removed and kept here. So your A is equal to BC and small a, and B is equal to C is also removed and it is kept here, and C is equal to B is added. So this is your grammar now. Okay, with removal of unit productions. But because we are removing, we have to do some changes in this grammar. So we will select one by one. Suppose I am removing B is equal to C. So if I am removing B is equal to C, so what is the meaning of this? We are saying that B is nothing but C. मतलब B will have all the rules which are there for C. Okay. So for this particular rule, we will have to add the we will have to change the grammar and we have to add. So C is equal to B. So whatever is there in C is assigned to B. So now I have added. See here, I have this was my input to the second step. Output of the first step is this one, and that is input to the second step of removal of unit productions. So input to the removal of unit productions contains all these records, all these rules, out of which I have extracted all the unit productions which are written down here, And without this unit productions, the grammar is rewritten here. And now because I'm removing b is equal to c, I have to do the change over here. So what is meant by b is equal to c? Means that whatever is there in c is also b. So here c has only a single variable small b. So that is there also, that this is also there for b. So we have to rewrite it. So we are rewriting it and adding b is equal to small b. And this is removed. Now this is removed from the grammar because we have added this. Now take the second one, that is a is equal to c. Okay. So for this grammar, now we are saying that a is nothing but c. Whatever is there in c is also there for a. So so here c is equal to b. So it will be b will be added here. Okay. So I'm adding b here. So now for a is equal to c ke liye I have done the changes. So remove this. So now this is removed. Okay, and this is my grammar. Now take the next one, that is a is equal to b. So we are saying that a is nothing but b. Okay. So whatever is there in b is also assigned to a. But here b contains only small b, and which is already there for a. So we don't have to do any changes. Okay. So it will remain same. B is written down here and it is same. Okay. So now this rule is removed. Take the next rule, that is s is equal to b. So for s is equal to b, whatever is there in b is also assigned to s. Okay. So so b is equal to small b. So b will be added to s, and now s will be modified. S will have b added. Okay. So now this rule ke liye we have done the things or tasks, and now remove this. Now the last one is s is equal to a. So for s is equal to a, whatever is there in a is also assigned to s. So for this, we will do the change and we will add BC, A and B, which was already there. A and B were already there. So we have just added BC to S. So for S is equal to A also, we have taken the precaution. Whatever is there in A is assigned to S. And now this rule can be removed safely. Okay, so now this is the output of the second step. That is removal of unit productions. Okay. So I suggest you, if you know already and if you can solve this problem, you start solving it. Okay, along with me. Okay. So there is a change here. Okay, so this was the output of the first step with the removal of null productions, and this was the output of the second step, that is removal of unit productions. Now take this as input to the next step. What is the next step? Remove the useless symbols. The first useless symbol is a non-generating symbol. Non-generating symbols are the symbols which are not generating any terminal string, means a combination of A's and B's. So the symbols means these are the variables. They don't generate the combinations of A's and B's. Okay. So we assume that A and B are generating for the first time. Okay, in the first pass, we assume that A and B are generating. Now identify who is generating A and B. So here, start from here. So it is A and capital B, but capital B is not in the set. So we cannot consider S. C A, capital A is equal to small a. Means who is generating small a b? That is the question that we have to answer. So small a b ka combination is generated by capital A because capital A generates small b. So with this rule, I'll say that that is equal to, no, here it is not like that. So here I'll say that A and B are generating symbols. So who generates A or B? So here we are solving this problem now. S is equal to A. Hmm. So this is the output of the first step, and then we have to remove the useless symbols. Correct. Sorry, I don't know why I got confused. So I think I was looking at the other slide. Okay, just let's go through again. This is your grammar, and the first step is to remove the null productions. This is the output of the null production after removal of C is equal to epsilon, B is equal to epsilon, A is equal to epsilon, and S is equal to epsilon. This is the output. That is input to the next step to remove the unit productions. And these are the unit productions. S is equal to A, is equal to B, A is equal to B, and A is equal to C, B is equal to C. Okay, so remove all the unit productions, and this is the output of that step. Now take this as input to the next step, that is removal of useless symbols. Okay, to remove the useless symbols, look at this grammar. Okay, so your A and B are the generating symbols. If A and B are the generating symbols, then you have to ask the question that who is generating A and B. So okay, so you look at here, because this is the input to this particular step, and here S is equal to small a or S is equal to small b. So S is generating A or B, so we can say that S is a generating symbol. Now see the try to check whether A is a generating symbol. A also generates small a, so we say that A is equal to small a or small b. Because of this, A is a generating symbol. C is equal to B. Because of this, C is also generating, and B is equal to small b. Because of that also, B is also generating. Means all the symbols are generating in the first pass only. So we include them in the generating ka set. This is the set of generating symbols. So S, A, B, C, and small a, B all are generating symbols. So there is no non-generating symbol. So there will not be any change, and the grammar will remain same. Okay, so I'm writing the grammar as it is the output of this particular state. So non-generating symbol was nothing, and all the symbols S, A, B, C are generating symbols. Now take this as input to the next step, that is identification of non-reachable symbols. For identification of the non-reachable symbols, you have to take the nodes like S, A, B, C, and draw the nodes. Okay, so draw first all the nodes, and now S is by default a reachable symbol because it is a starting symbol. So try to find out the rules. But the first rule is S is equal to AB. So because of this rule, from S you can reach to A as well as to the B. Or with this rule, AB from S you can reach to capital B. Okay, so I'll say that with S is equal to AB, with S is equal to small AB, A and B are reachable. And A from A you can reach to B via this BC. Even from A with BC ka rule you can reach to C. Even there is S is equal to BC, so with that also you can reach to C. Means all these nodes are reachable. So we can say that S, A, B, C all are reachable symbols. The final grammar will remain same. Okay. Remember, you have to practice this. You have to practice this because in the Chomsky normal form and Grayback normal form, first you have to simplify the grammar and then you have to use the steps of normal form. Okay, so this is done. Now this is the final answer. Because all the symbols are reachable, there is no change in the grammar. Okay, so we'll see one more problem. Now you try and solve the problem on your own. This is the last problem of simplification which I'm going to take in the class. So you try to solve and then see the solution which I'm showing you in the slides. Okay, so here this is the grammar. This is the grammar with the four variables S, A, B, and D. Now these are the rules. First step of simplification is removal of epsilon. So here there is no epsilon production. So now in the step one, we can say that there are no null productions, so P will not change. P will remain as it is. So this is same as the input to the next step, that is removal of unit productions. For removal of unit productions, identify what are the unit productions. So unit productions are S is equal to A and S is equal to D. So write down, identify and write down separately. Then write down your grammar without that rules. So I'm writing the grammar without that rules. Okay. So Write down the grammar without that rules. Okay, so here your grammar is there. There is no epsilon symbol, so there is no change. Now identify the unit productions. These are the unit productions. S is equal to A and S is equal to D. So without them, you write the grammar. So without them, write the grammar. Remove A and D and write the grammar. Now you take the first rule. S is equal to D or S is equal to A. So if I'm taking S is equal to A, for that, what will be the change? So what is the meaning of this? S is nothing but A. So whatever is there in A can be assigned to S. So I'll say that S is equal to, actually I have to remove this D also. Okay. So this is, so we'll remove that. So this is not there. Okay. This is by mistake. So add A. S is equal to small a. Now take the next rule. That is S is equal to D. Okay. S is equal to D may, you can also again, so here S is equal to, yeah, this D is not there now because we have removed it. This is the input, and now S is equal to D ke liye. The meaning is that S is nothing but D. So whatever is there in D is assigned to this. Okay, so with this removal of S is equal to D, you get the output as, mm, S is equal to small as, and S is equal to small as and small a and ADP. Okay, now directly also you can see now whether how to do this. I'm removing S is equal to A, so I'm assigning small a here. Okay, so that's small a here. I'm removing S is equal to D, so whatever is there in D is written down here. Okay, so that whatever is there in D is written down here, and this is the output. Okay, so it was a simple step: removal of null production, removal of unit productions. Now this is the input to the next step, that is identification of the non-generating symbols. So here small ab is a non-generating symbol. Try to find out who is generating small ab here. By this is the input to this particular step. So S is equal to small a, S is generating. A is equal to small a is generating. B is equal to double a, B is generating. And then C is equal to, C is not there. Okay, C is not there here. So this particular, this is not there. Okay, so with this we can say that S, A and B are generating. So SAB and AB are generating symbols. If these are generating symbols, then D is not a generating symbol. You try to remove D, but we are not able to remove D. So we say that D is a non-generating symbol. So remove D and write the grammar. With removal of D, if you are writing the grammar, your grammar is S is equal to AS or A is equal to small a, B is equal to double A, and D is removed. Okay, so now this is the input to the next step, that is non-reachable symbols. So assume that the non-reachable symbols by drawing the graph. So draw S, A, and B. And now look at these rules. S is equal to AS. So S is reachable from S. S is equal to small a is like it's remaining there only. And A is equal to small a, B is equal to double A. So there is no way to reach to A and B because S is equal to, there is no rule from S to reach to A. Okay, so here we can say that A and B are not reachable from S. So my final grammar will contain the answer as S is equal to small as or small a. Okay. So I think we've taken sufficient problems, 3-4 problems of simplification of the context-free grammar. What we have done is that take the grammar, I remove the null productions because we have to remove the null productions and identify all the direct null symbols, null productions and indirect null productions, and for every null production go on adding the rules. Then remove the unit productions. For every unit productions you have to just assign the value of that right hand side of that variable to the left hand side variable. So like this, you remove unit productions, add the new rules. And then the third step is to remove non-generating symbols. First, you identify all the generating symbols and the remaining symbols are non-generating. So remove them, okay, from the grammar. And then draw the graph with the directed acyclic graph. You can find out the non-reachable symbols and identify them and remove them and write the final answer. Okay. This was about the simplification. Okay. Now in this grammar, as we know, this grammar is VTPS. And the rules for the context free grammar are of the type of A generates alpha. Okay, so we are moving on to the next topic now. That is Chomsky normal form. So in this normal form means that you just have to rewrite the grammar as per the specified conditions. Rewrite the grammar as per the conditions. For Chomsky normal form, what are the conditions? There are three types of conditions. Your rules are should be of the type of A is equal to BC. Okay. See, now we are going to learn about Chomsky normal form. Chomsky normal form means conversion of your context-free grammar to CNF. What is meant by that conversion is that as per the Chomsky normal form, each of the rules should be of this particular type. Okay, and what are the types? A is equal to BC is the type. Like left hand side is a single variable and right hand side are two different variables. Means all the capital letters are there. And left hand side is a single variable, right hand side should be two variables. Only two variables, not more than two. And both are variables. Or your left hand side can be a single variable and right hand side can be a terminal symbol. So it will be a single terminal symbol at the right hand side. So single small case letter. Or left hand side can be a single variable, but right hand side should be can be epsilon. Okay, because it is a type of context free grammar only. CNF is also a context free grammar. So as it is a context free grammar, left hand side is a single variable. So there is no change in that particular rule. But the change is there in the normal form is that right hand side के लिए कुछ constraints हैं or some restrictions are there. And what are the restrictions? It can be two variables at the right hand side or a single terminal symbol or it can be epsilon. Epsilon and single lowercase letter is allowed, but more than one lowercase letters are not allowed. Even more than two variables are not allowed. If variable is there at the right hand side, there can be maximum and minimum two variables. So exactly two variables at the right hand side. Okay. So if all the rules are converted in this format, we can say that it is a Chomsky normal form. Your context-free grammar is in the Chomsky normal form. And then what are the steps here? There are three steps. First step is to simplify the grammar. So अपना simplification का all four steps are there. So simplify the grammar. After simplification, you start converting into CNF format. So to convert it into CNF format, you first select all the rules which are already in CNF format in the answer, and then for every non-CNF rule, you will have to do the changes by adding a new Chomsky variable. Okay, and you have to just do the adjustment in such a way that right hand side contains two variables or terminal symbols. Okay, so let's see with the help of example. Okay, so for example, suppose a grammar is given to you, then this is a grammar. So remove epsilon productions. So here, see, there are only 10 minutes are left. So I'll just show you the problem. We will solve the problem next time. Here, the first step is simplification. Removal of epsilon is done here. For A is equal to epsilon, B is equal to epsilon. Go on adding the rules here right hand side. Then remove unit productions. Then take the generating symbols, non-reachable symbols, and simplify the grammar. So first step is the simplification of the grammar. After simplification of the grammar, you just always the trick to solve the problem is that as a first step, if your terminal symbols are small a and small b, take two variables always, CA and CB, as two variables. It is a variable, capital C, but small a is a subscript. So I've added two Chomsky variables in my rules. See, in my rules, there were S, A, and B were the variables. So add a new variable CA and CB in the grammar, and say that CA is equal to small a and CB is equal to small b. Then you take each and every rule and start converting into Chomsky normal form. So here CA is equal to A is added in this right hand side shows the answer to my question. So CA is equal to small a is in my solution, CB is equal to B is in the solution. Now take the first rule, S is equal to AB, AB. It is not in the Chomsky normal form. So you can convert it into two parts. So say that S is equal to C1, C2. So I've added new variable C1 and C2, where C1 is equal to AB, but A is equal to CA and B is equal to CB. So write C1 is equal to CA, CB. So there are two variables at the right hand side. Then for AB, you can say that C2 is equal to capital AB, which are already two variables. So, okay, so this single rule is replaced with three different rules. This way you have to go on selecting the rules and go on modifying. Now the second rule is ABA. So say that suppose S is equal to C1A, because my C1 is equal to AB, CACB. So here directly I can say that AB means C1, because C1 is equal to CACB and CA is equal to A and CB is equal to B. So for AB I can say it is C1 directly. So it is C1A. S is equal to ABB is the next rule of my grammar. So I say S is equal to C1B. So like this, you have to go on looking at the variables and start working on that. S is equal to AB के लिए you can write down CACB. Then A is equal to small b, AB के लिए you can say that now there is no option. So add a new Chomsky variable C3. So it will be suppose C3B, where C3 is equal to CB capital A. So you have to write down everything in the form of two variables at the right hand side. If the rule is A is equal to small b capital B, then write down this B as a CB. Or A is equal to small b A, then write down this small b as CB. Okay. Then A is equal to B के लिए it is allowed. It will remain as it is. Like this, these many rules were there. So all the rules are changed. And now in my grammar, I have S, A, B, C, A, C, B, C1, C2, C3, and C4. All these many variables in VTPS. Okay. So this way you will have to go on selecting every one particular rule and convert it into the Chomsky normal form. What is the meaning of Chomsky normal form? Is that your right hand side should contain two variables, maximum two variables. So if there are three variables, you divide them, break them into two parts and create a new variable and add a new variable in the grammar. So in the grammar, finally, you were having only SAB in your grammar. And now 3 plus 3, total 6 variables are added in the grammar. And this is the new grammar. Okay. So this is done. So we will solve one more problem of Chomsky normal form in next time, and I will teach you some steps of Grayback normal form. Chomsky normal form is easy. Grayback normal form takes time to understand. Okay, so we'll stop for today's. Any doubts regarding the ISC Council